Hello everyone, my name is Antonio and I'm here to briefly explain some of the GenAI capabilities using my project. The project is part of the 5-day intensive Google Generative AI course. If you're not an expert in AI, don't worry, neither am I. Building this application, I had to study extensive course materials, other similar documentation, YouTube videos, and I used AI's coding capabilities to my advantage. My aim is to make architecture and techniques I use in this project less technical and more understandable, starting with RAG. RAG, or Retrieval Augmented Generation, is a tool used by an LLM to locate and output relevant data. I'm not going to go deep into the LLMs, but you need to understand that they are a type of artificial intelligence that can understand, generate, and manipulate human language. Some of the basic RAG techniques include data chunking, embeddings, vector storage, semantic search, and context augmentation. I know that throwing around all these names make RAG seem very complicated, technical, and straight up confusing. So let's try to simplify them and break them down. Firstly, using the function you see on the screen, we can store large amounts of data in chunks. In my case, I used a library of 20 PDF files of Boardgame rulebooks. These chunks follow some set rules like chunk size and chunk overlap, as well as some of the patterns that are relevant for a specific data. Imagine having a bar of chocolate. Every line of chocolate is a chunk. Line size is the chunk size, and overlapping is when you try to break a line of chocolate only to end up with part of another line. But in the case of text chunking, the data from next chunk is not lost. This method helps to keep context from previous chunks in case size is not encapsulating all the information needed. In my code, I used parameters like game setup, gameplay, and end of game as a way to use patterns mentioned in the rulebook for creating new chunks. This is similar to companies engraving their company name or logo or a shape on each piece of chocolate. After the data has been chunked, it gets stored as embeddings. It is also assigned metadata and ID. For clarification, embeddings or vectors are small numeric values that store data as well as its metadata. What this means in our unavoidable chocolate analogy is that chocolate lines now have different shapes or metadata or tastes or IDs. One chocolate line may be made of hazelnut chunks, while the other is filled with strawberry. Embeddings are invaluable for faster and easier locating and retrieval of most relevant chunks of data by using assigned metadatas and IDs. Chunks and embeddings are both called in a function process game rulebook in my code. Also, the function extracts text from PDF, which is necessary for my use case since the libraries I'm using are imported PDFs. The function also stores every vector embedding in ChromaDB database, which is an open source vector database. This way, base for the RAG is created. It now has a database of all the necessary chunks and their embeddings, and is ready to retrieve them. After a user inputs a query, it is then transformed into its own embedding. This query embedding is then compared to the ones in ChromaDB collection, and only text chunks relevant to the query are then returned. Now that the code has the query embedded and processed and it retrieves the most relevant chunks, RAG uses the value and its context alongside an AI model to generate response. And there you have it. That's how RAG functions. Even though the parts of code I explained all closely relate to RAG systems, there are other code blocks necessary for this code to run more efficiently, smoothly, and cleanly. One of these we already mentioned and explained, that is extracting text from PDF using PDF Plumber. Two ways to make code neat and more efficient are logger and rate limiter. Logger makes the output limited, and instead of showing steps of extraction, embedding, and processing, it shows the response only. This can be beneficial for limiting the output tokens, but it makes those errors while extracting text undetectable since the application still works, but errors are being hidden by the logger. Rate limiter does just as the name suggests. it limits rates. In my project, I chose Gemini 2.0 Flashlight model. Its free version has only 30 RPMs or requests per minute limit. So using rate limiter, I ensured that my application will be able to extract and process data without any issues. Although this could be avoided using paid version of the AI model, it also limits the experimental purposes of the application. One of the issues I encountered that were connected to both extraction quality and rate limit is implementing image extraction from PDF and the text extraction from those images. Some helpful user interface functions that I implemented are creating rulebook indexes and checking if the rulebooks are processed. Creating indexes creates a list of available game rules without processing them. This way, a user can pick a rulebook to be processed. On the other hand, checking if the rulebook is processed helps the application save time and processing power in case a rulebook has been opened. It's like having wrappers with different names or indexes holding chocolates with all those different flavors and fillings and checking if any wrapper has been opened to see what kind of flavors you're going to get. Thank you for listening, and in case you want to know more about my code or AI in general, check out the link in the description. For some reason, I'm craving chocolate now.